This is the part we skipped yesterday. I wanted to kind of let you get the hang of strong acids and strong bases and how to find their pH and their pOH. And now we just need to kind of contrast that to weak acids and weak bases, okay? And we're not going to really find the pH of them, but I need you to understand the big differences between them. First big difference. What do you see on the board that's the biggest difference? Thank you. They do not 100% ionize, okay? So basically, I keep saying basically, we have reactants, and they're going to be either a weak acid or a weak base, and they reversibly react. A two-headed arrow means reversibly reacts, or it's a reversible reaction, or it comes to equilibrium. There's lots of different ways to say that, okay? So if a two-headed arrow is there, it's probably telling you, hey, I'm a weak acid or weak base. It's kind of a easy trick to see. So whatever the reactants are, they will yield some products, but yesterday I was like, oh, 0% reactants are left, 100% products are made. Now we're going to have like, I don't know, it's going to vary. I'm going to say 95% reactants are left. A lot of them are left, right? And only merely 5%, 1%, 2%, something really low products are made. Basically, the thing is not really dissociating. It's not ionizing. It's not separating, which means it's weak. It's not going to make the pH nearly as low or nearly as high like those two extreme strong acids and strong bases can. So here are two examples of how they are written. The HA that's just a generic way to write weak acid. How do you know it's an acid though? Straight off the bat. It's got an H in the front, and when it reacts with water, it does so reversibly with a two-headed arrow to make a little bit of the hydronium and a little bit of whatever this anion is here. So yet again, you could say, oh, you know, like 2% of the products are here and 98% of reactants are left. So that's what I just did in the more simpler way up here. Same thing with base. It will go reversibly. So those are the two types of reactions you might see. And then there's a way, there are numbers to help show the weakness, and I have that on the next slide. These numbers are just ways to say, you know, they're really, really, really low in ionization rate or dissociation, and so the higher the number, the stronger the acid. The lower the number, the weaker the acid. So I'm going to show you the differences here in just a second. I'll give you guys another second there. These slides are all mixed up, though, so I'll show you here. Oh, and I didn't show you this. I'll come back here if necessary in just a moment, but I'm going to go to the next slide first because I'll try to get you started back. Okay. The picture here will show you kind of what I mean. You can see that HCl, you know it's a strong acid. 100% of this HCl breaks up in the H pluses and Cl minuses. 100% always. They will always be apart. And then over here, you can see this is H and acetate. So what's the name of this one? Acetic acid, right? Acetic acid is bound by that little bond there. How many of them broke up over here? Just one. Just this one here broke up. These two are still present in that bound location, or that binding spot. So partial neutralization or partial ionization is another way of saying that. It is not 100% ionized. That's why it's easy to see in a picture form which is weak and which is strong. Same thing here. You see all these bound up acids, and then these are all broken apart? 100% ionization. This one, they're all bound, and then a lot of them are still together. That means it's not 100% ionization, so that would be representing a weak acid. Okay? So you can see it from picture forms as well. All right, that's not what I was going to show you. This is, sorry, a couple slides away because I skipped it yesterday too. Here it is. Oops. There. Okay, so the pH of weak acids and weak bases will vary, okay? But they're going to, we just write down this, they only partially ionize in water. We use these values. I was telling you there's a number associated with it. The numbers are called K values. And next unit, we're going to really focus on what this K means. But the Ka, what do you think the A stands for? Acid, and Kb stands for base. That's helping to see like the true weakness of something. How weak is this acid or how weak is this base? we can use these values and we can actually use them to solve for hydronium and hydroxide. We're not in this unit, but we are in our next unit. So we'll kind of refer to this again, but you need to know the significance of these values. So HI, is it a strong acid or a weak acid? Strong acid. This reversible arrow, this is a lie, okay? It does not, like once this H and I break up, they do not go back to the HI, a hydroiodic acid form. And so the way that we can indicate that with a Ka number is say it's very large, meaning 100% products are made. So a Ka that's really, really large, it literally, we don't even have a number for it. We just go, hey, it's really large, very large. That means it's a really, really strong acid because it makes a lot of products. So what would you say about a weak acid? What would the Ka value be? Very low, like 10, like 1 times 10 to negative 10, something really low. So here's a couple of examples of that. I'm going to scroll down. Is that okay? No? No? Yeah? Yeah? I see scared faces. I'll give you a second there. So you can see HBr, HCl, nitric acid. What do they all say for the Ka value? Very large, very large. Okay. And then sulfuric acid, this is what Savannah was asking earlier. She's like, do you double it? No, it only breaks apart 1 H at a time. So that first association is large. And then we can start to see some numbers here. 10 to negative third, 10 to negative fourth, 10 to negative fourth, fifth. So HF, hydrofluoric acid, it's not a strong acid. Okay, look at the Ka value. 3.5 times 10 to the negative fourth. That means that there's little products made. Yeah, what's up? Yeah.
Where do you get this from?
From a book. If they're like standard values, I would always give them to you. But I just want you to know the significance of them. Small numbers, low products, very little products means weak acid. Yeah.
Can you scroll down?
Just a second. Let me just go down the bottom of the class one more time. So you can see there's lots of examples here. The K, oh look. Why is this value significant? Right, it's the Ka of water, 1.0 times 10 to the negative 14th. Water is a really, really crappy acid. It's also a really crappy base. That's why it's a good thing to use for most of our solutions. But it can be acidic or basic because it can have H plus and OH minus is made. And then this one's very small. The Ka value of this is really small. Why does that make sense? Is that an acid? What's ammonia? Is it acidic or basic? It's basic. Ammonia, that was one of your substances back there you're testing. It's a cleaning agent. A lot of time cleaning agents are pretty basic, like Drano and stuff. So this right here is basic. So it's got a really, really tiny Ka value because it's like not an acid, period. And then I think I have a couple more here for you from bases. So, oops. Do I have bases? No, I don't have the KVs listed. But you have all these Kas listed. All right, and I think that's all I'm showing. Mark, I'll go right back. I don't think I have anything else here. That was the indicator website we didn't do. Probably tomorrow or Monday, I would expect a quiz on pH. Tomorrow, I might just do definitions. Arrhenius does what? Arrhenius, aqueous, you're talking about what it does in water. What does an acid do in water? Ionizes to make what? Hydronium. What does a base do in water? Makes hydroxide. What does a conjugate, what's a bronze lauric acid? It's a bad acid, right? So it does, I love that. It's a donor of protons or H pluses and bronze bases, acceptors of protons or H pluses, right? Lewis acid, it does what with electrons? Gives them or accepts them? Lewis acid acceptor. Acid acceptor, only for the Lewis acceptor of the lone pair of electrons. Lewis base? Shares. It's a share. It's a carrier. Okay, yeah. I'm turning the announcements on for real. Reading guide on your desk, reading guide on your desk. I'll come see you in just a second, okay? You got it, Mark? You wanted to see that?
Yeah.